All right. Page 44. Write the inequality for the following scenarios. Make sure you define the variables. Okay, so we want to make sure we do that unless I tell you right from the get-go what X and Y is. All right. So a fridge displayed can hold up to 900 cubic centimeters. So X would be the capacity, right? Fridge capacity in centimeters cubed, right? So that's what we're talking here. And so that capacity in this case has to be less than or equal to 900. And in this case, we don't add any units there, okay? Because we already defined our variable. In my key, I may have defined it a little differently, perhaps, but same idea. In the order for the university to offer a Spanish course, it needs to have at least 12 students registered for it. Okay, so we'll let X be the number of students in Spanish. Okay, something like that. And in this case, the units are number of, right? So you could just say students in Spanish, and that would be number of students, right? So X would have to be greater than or equal to 12 in this case. The word at least indicates that it's 12, 13, 14, 15, anything above 12. So ask yourself, does this statement is only true if X had been 12, 13, 14, right? That's the only time this statement would be true. So you're testing it. A farmer grows potatoes and sunflowers. Oh, okay, there's two different things here. In order to profit, she needs to harvest a combined weight of 1,500 pounds. So this is a little different, right? And I do go by the units that show up, right? So I will let X be potatoes, and I put down that this is in pounds, and sunflower. Morning. Sunflowers in pounds. Okay. So combined, right? Combined. I don't know why I wanted to do B. MX plus B maybe. X plus Y. The pounds combined. She needs to harvest. She needs to harvest this or more. That is the implication. So you want the pounds to be at least 1,500 pounds. If you were to harvest that combination, you want it greater than or equal to 1,500. And just think about it. All of these we could graph right now. All of these can be graphed. This is a vertical. This is a vertical. This would be a diagonal, right? So that's where we're kind of going towards. A daycare takes care of toddlers and preschool children. Based on the staffing, it can accept up to 50 children combined. So X would be number of toddlers, and Y would be number of preschool, right? And so both X plus Y up to that amount has to be less than or equal to 50 in this case. Some of these will repeat later on. You'll be like, we did this, right? I don't want to graph right away. I used to do, let's come up with inequalities graph right away, but the most important piece is to get this right, to write it correctly. Okay, so that is the goal of these two pages here. So now it's going to get a little bit more complicated. Now you're given information, and you're going to have to write various inequalities that all revert back to this scenario. Okay, so let's see how we did here. Spence, a DJ, is often hired to play at birthdays and weddings. Okay, a birthday event usually takes 3 hours. A wedding takes 5 hours. So I don't know if you noticed that, right? The variables are most likely birthdays and weddings, right? And then we're told that both of them take a certain amount of time. It relates to the variables, right? including setup and cleanup. He earns a flat fee of $450 for a birthday, $625 for a wedding. So I don't know if you noticed that. How about highlighters? You're either gonna love highlighters or hate highlighters after you're done with me, right? Birthdays and weddings, right? I don't know. I want you to see some patterns here, right? I'm modeling how I would come up with the inequalities. And so here again, right, you have that birthday and birthday. And then you have the wedding and the wedding. Okay, so things are happening here. So I think it's safe to assume that birthdays and weddings are going to be our two variables. So we'll let X be the number of birthdays. Just be careful you don't mix them up, right? I usually do the first is my first variable X and the second event or variable is Y. So number of weddings. And I will be picky with a lot of students just do that, birthdays, weddings, right? Be specific with your units because sometimes it's going to be, they're going to be different units attached to it. Okay, maybe it's the amount you made for a birthday or the amount you made for a wedding. Okay, so this is good. The next thing you're going to have to add, because this is a word problem, you're going to have to say that both X and Y have to be greater than or equal to 0. This is technically the domain and range. This is what we call the implicit constraint. Implicit constraint. You can rephrase that an implicit restriction or the assumption we're making, right? Implicit, explicit is very obvious. Implicit is it's not quite stated, but it's assumed that that's the case. Okay. All right. So we know this. Let's go to town here. Spence has at most. That is a key word there. At most tells you that that's an inequality. 40 hours per week available. Okay. So we have 40 hours per week available. Careful here. This is the first instinct, perhaps. You're going to just go X plus Y, right? And this has to be at most 40. So that means, right, the number of hours. And there's something missing here. Because we're talking hours, I'm going to circle hours, right? There's 3 hours here and 5 hours there. So you're going to have to go 3 hours for every birthday, and it takes 5 hours for every wedding. So you're going to have to put the coefficients in front of the X and the Y here. Okay? This is a restriction on hours. Restriction on time, right? And so notice that it's a little different here. You have those coefficients in front of it. Next, Spence would like to earn at least $2,300 per week. So there's the keyword at least, and you're making money, right? This is money. Okay. Let me rephrase that. This one right here is going to have a restriction on money. Okay. If you did this already, just enjoy the ride, right? Just come with and maybe make little notes here and there, which is awesome if you did this at home. That's kind of what I'm expecting. You get a second go at it, right? Just looking at it a little differently, maybe, and putting it together. So you're making money. So we go back to the money here, and in this case, you'll have 450x, right? Plus it costs, or you make 625 for every wedding. And this amount that's going to come out of it, because you're going to perform at weddings or birthdays? Well, maybe just weddings, maybe just birthdays. However, that combination, you want it to be at least $2,300. I hope that makes sense. Okay. Spence would like to DJ at most 9 events combined per week. Restriction on events. So technically I could go up here, and this would have been better to say number of birthday events, right? Number of wedding events. But the combination of those two, right? The number of birthdays and the number of weddings, at most 9. Notice that there's just one, right? One in front of this, one in front of that, because we're just dealing with the events themselves. He would like to DJ a minimum, there's that keyword again, a minimum of 2 weddings per week. Okay, what's this happening here? It's just talking wedding, right? So a minimum of 2. That means that the number of weddings has to be greater than or equal to 2. It's specific, only involves Y, right? This will be a horizontal. This will result in a horizontal line in this particular case. Oh, define your variables and write all the inequalities. I already did that. So kind of too late, right? Should have been up here. Anyway, so this is what you want to kind of get used to, something like this, right? Where you get a scenario and you have to take out the hours. Okay, this one here, this one talked about hours, so those coefficients are going to be in front of my variables. This one talked about money, so I'm going to go see if there's any money attached to those variables, and sure enough, right, it was there. This one didn't talk, this one is just the events themselves, so there was only X plus Y. And I'm going to tell you, it's going to be a learning curve for you to get this, to be able to do this. Maybe right now you were able to follow along, but once you have to do it yourselves, sometimes you're like, wait a minute, what is it saying? What? Wait, what? Is it vertical, horizontal? Is it both? Right? So you got to watch out for that. Okay. Let me see here. I would like you to try. See how you did. Pretend like this is your AC and you're marking it. Food stand sells pulled pork sandwiches and hot dogs. Probably it, right? It's probably your X and your Y there. The cost to the owner of the food stand is $1.25 per sandwich and 50 cents per hot dog. So there's your sandwiches. There's another sandwich there. And right, you have your hot dogs. It's not always going to be like this. I'm kind of still, we're learning how to deal with these. So I make it a little quite obvious as to what the variables are. Usually the first sentence tells you what's going on, what the variables are going to be. The owner of the stand has a budget of $750 for all supplies needed to sell both products. So basically what this is saying, if you have a budget of $750, right, it kind of is saying you have up to $750 available, right? That's what that is saying. You know, I have a budget of $750 for groceries this month. It means that I have up to that much available to me, right? So we will say in this case, a cost, right? So you need to watch out. There's dollar amounts in this line and there's dollar amounts there, but we're talking cost right? So we're going to take this with us and put the $1.25 X and the 50 cents per hot dog, okay, like that. That has to be, the cost that is associated with that has to be less than or equal to $7.50. Okay, so that's how you would write that. A food stand has enough supplies to serve up to 650 sandwiches and hot dogs combined. So we're talking about the number of, I didn't define my variables, right? Uh-oh. It's supposed to be done down here. It doesn't matter. I will just say let X be the number of sandwiches. Let Y be the number of hot dogs. And the implicit constraint would be somewhere, when it's a word problem, you just put this down to make sure you don't lose marks, right? So I defined them. I made everything positive. Can't have negative hot dogs, right? A food stand has enough supplies to serve 650 sandwiches and hot dogs combined. So the number of sandwiches and hot dogs combined, right, has to be less than or equal to 650. That's what that is saying. Okay. The emphasis is on combined, right? That is usually both of them together, not just one of them separate. The owner would like to profit, right? Profit at least $1,000. So the profit comes in here, right? When it comes to profit, so it's $2.50 per sandwich and $1.50 per hot dog. And that has to be at least, and it kind of makes sense, right? You want to make as much money as possible. So at least $1,000 that you want that combination to give you, okay? The owner of the stand would like to sell at least twice as many sandwiches for every hot dog sold. This one is tricky. Okay. At least twice as many sandwiches for every hot dog. So this one would be like this. I will compare, you're comparing sandwiches and hot dogs, right? And think about it this way. Twice as many sandwiches as hot dogs. So this is telling you that there's more sandwiches sold, right? So you would definitely have one of these. Where does the 2 go? In front of the hot dogs or in front of the sandwiches? It's counterintuitive, but it is actually going to be in front of the, make sure I get this right. I have to think. Okay. Twice as many sandwiches for every hot dog sold. So yeah, it's supposed to go in here. So I mixed it up now. I apologize. I mixed up hot dogs and sandwiches. Let me redo this. I mixed it up. So you want more sandwiches sold, right? Twice as many sandwiches as hot dogs. So you want this to be greater. Sorry about that. I'm terribly sorry for that. You want the sandwiches to be more. And the 2 will go in front of the hot dogs. It goes in front of the hot dogs because you want this, the number of sandwiches, to be twice as much as the number of hot dogs. So let's do a little experiment. If you sell 1 hot dog, right? That will, right? Like you'll have sold 1 hot dog, but twice as many sandwiches for that reason, for that matter, right? It'll be 2 is greater than or equal to X, right? So for every hot dog, you want this to be twice as much as you sell hot dogs. It's counterintuitive. So these ones don't appear very often, right? But this is what it would look like. So if you put the 2 in front of the X, then, right, then you're saying the opposite. Scratch your heads on that one. So you sell twice as many sandwiches for every hot dog sold. These are your hot dogs, right? So let's say you sell 100 hot dogs. You want this number to be greater than or equal to 2 times the hot dogs you sold. It's counterintuitive, right? Let's say you sell 300 hot dogs. 2 times 300, you're saying that the number of sandwiches will be 600 or more. Let's say you sell 1,000. Let's stop right there. I'll just stop right there. Anyways, do you want to do 4 quick? Let's do 4 as well. Did you do 4 already? Some of you still need some time. My problem is time. That is my problem. So we'll do it together. 2 part-time jobs, working at Canadian Tire and Wendy's. Hey, that's a good combo. So she earns $11.45 per hour at Canadian Tire, and at Wendy's $12.50. Emily would like to work at most 30 hours per week. Canadian Tire requires Emily to work a minimum of 9 hours per week. Emily would like to earn at least $225 per week. Define your variables, then write the inequalities. Here, this is where this one is the toughest one when it comes to setting up. So this will be Canadian Tire, and this will be Wendy's. And it should tell you that something is wrong with that, right? The units are missing here. And this is really saying hours at, right? And this is also hours at. Hours spent working there. So I don't know, was this on the key? I'm not so sure. I may have. So let's talk about, it's just telling us our wages. Emily would like to work at most 30 hours per week. So let's focus on this one here. How about I write it right next to it? X plus Y, the number of hours spent on both working for both companies, is going to be less than or equal to 30. Okay. Canadian Tire requires Emily to work a minimum of 9 hours per week. So it's just Canadian Tire has to be greater than or equal to 9. Okay. Has to be at least 9 hours. That's specific to Canadian Tire. What about Wendy's? Could be anything, right? There's no restriction on that. But there's this works in tandem. These two, when you graph them, things are going to cancel out, and you're just going to be left with a solution region, right? Emily would like to earn at least $225 per week. This is where the $11.45 for Canadian Tire, right, worked at Canadian Tire, and the $12.50 worked at Wendy's, has to be greater than or equal to 225. So there you have your 3 inequalities in this case. I don't know if it would be beneficial to just have these here highlighted, right? Because that is the only inequality in this case that has coefficients other than 1 in front of them. All right. So again, you're wrapping your head around this concept, right? So we're practicing. So let's actually graph one. Okay. Let's take this further. Okay, I'm debating here. I usually start off with just one inequality. Just one. I feel like it's going to be a bit too easy. So we're not going to graph these. We're not going to graph these. I'm just going to ask you one more time before we do an actual graphing one. So don't graph any of these. I want you to just write the inequalities that you see here. Write them out. Define your variables. This is what I mean. And the first one, it's going to be motorcycles. I'm giving that one away. And y is bicycles. And the units would be number of, right? So you definitely have to do that. Then you have to state this implicit constraint. Then you write the inequality here, okay? So kind of go through that step before I do one example with you, okay? So write these all out. See how the inequalities, make sure they're pointing the right way. That's very important, or else your graph will be off. So this page and the next page as well, and then we'll do a graphing one, okay? So just, oh, it's frozen. There we go. Let it go. Anyways, motorcycles, bicycles, right? Number of, I gave that one away already. Implicit constraint, that's what it should look like. I'm just going to make a note moving forward. What kind of data am I looking at? And this would be discrete. Just going to make a note here because you will see the POIs are going to be rounded in this case. Discrete. Hours spent studying, right? So hours studying math, hours, so that is continuous. Continuous. I'm missing something there. Continuous data, right? Question 3. Touring cycles, racing cycles, right? 300x plus 400y has to be less than or equal to 8400. That would also be discrete. I'm looking at the variables, right? Number of, it has to be an entire number. That's why it's discrete. Keep going. 47. And these are the ones you need to watch out. You can't just put cake requires one cake and different cake, right? So this would be cake 1 or cake A, cake B, so to speak. But it's not just, it's going to be grams. Hold on. No. We're good here. Number of. I was going to say something, but never mind. Number of. So it's 150 grams for X, sorry. 150 for X and 75 for Y. And that is at most, right? 2.25 kilograms is available. You got to multiply that by 1,000, right? To get 2,250 grams. Because if you have grams to begin with, you need to make sure you have that. So this has to be less than or equal to 2,250. Okay. So that's a little curveball there. Bakery can make no more than a total of 600 muffins and bagels in the morning. So this would be muffins. And Y is bagels. And X plus Y. They're all less than or equal to. I have to rewrite these. And that would be discrete as well. One type of shelf requires 2 brackets. Another type requires 3 brackets. Total of 42 brackets are available to put on several shelves. So we'll do this. It's not about the brackets, it's about the shelf, right? We'll do shelf A. And this will be shelf B. Okay. And I'm forgetting the implicit constraint because I'm rushing. Okay. Did you see number of? Nick is paying attention. Yeah. Yep. Number of. And this would be 2 brackets. So 2 brackets times X plus 3 brackets times Y. And what does it say? A total of 42 brackets are available to put up on the shelf. So you don't have more than 42, right? So however many shelves you're making of each type, you only have 42 brackets available. So you are restricted there. That's what that should look like. And this one, I'm just going to write it out. Okay, so that'll be 200x downhill skis plus 150 country skis, and her order cannot exceed 6,200. I need to rewrite this handout because it's all less than or equal to. But you've seen it going the other way as well. Okay. Okay. So I'm going to stop there and then make another video.